Welcome back to this video. In the previous video, we looked at what exactly is Euclidean geometry. Then we looked at applications of Euclidean geometry in different professions. Now we're just gonna look at some fundamental concepts that were covered in earlier grades, be it grade 9 and grade 10. So we're first gonna look at like straight lines. We know that all the angles on a straight line, they add up to 180 degrees. That is an important aspect. And then we know that angles around the point, they sum up to 360 degrees. Then vertical opposite angles are equal. In this case being O2 is equal to O4 and O1 is equal to O3. Should be knowing this. Then you look at the parallel lines. If we've got two parallel lines, we can use corresponding angles, alternate or co-interior angles. Corresponding angles, they form an F. As you can see here, angle F1 is equal to angle A1 because there's an F formed. That is corresponding angles. Then we've got alternate angles, which are your Z or your N. In this case, you can see that F1 is equal to B1. Then we've got co-interior angles, they form a U. But co-interior angles they add up to 180 degrees, being A1, angle A1 plus angle B1 is equal to 180 degrees. And so need to note that your F can be upside down. You can see here they gave you a normal F, but sometimes you'd find your F being like that. You'd find your F being like that. So you need to be able to visualize your angles even if it's not the normal F, where your F maybe is like upside down. Same thing with your N or your Z, can be like that, or it can be like that, it can even be like that. So you just need to help it, just need to be helped by your eyes to be able to spot these things. And you could be that U, or it could be like that. And then so now we know that if you've got parallel lines, angles that form an F, they are going to be equal like that. But now I want now to show you this. So I'll show you the converse of this now. What is a converse? A converse is a reverse. So we know that if you've got two parallel lines and the angles they form an F, so they're gonna be equal. So that is going to be equal to that angle. What is the converse of this? The converse is the opposite now. It says if I've got these lines and then I say to you these angles are equal, you see, but I don't say that these two lines are parallel. I shall say these two angles are equal. You're gonna conclude that these two lines are parallel. This is what you call a converse. We are reversing. Another example, I'm gonna use an N. So if I say to you these two lines are parallel, what you conclude? You conclude that these angles are equal. Now suppose that I just give you an N like that, and I say these angles between this Z or N are equal. You should conclude that these two lines are parallel because this is the converse of the alternate angles. So we use this a lot when you ask to prove that two lines are parallel. You need to prove that angles that form an F are equal, or angles that form a Z are equal, or angles that form a U add up to 180 degrees. But you'll see as we do more questions. But that's how converses work, just reversing. And we use converses a lot in Euclidean geometry. If we look at triangles, you must know that the sum of the interior angles of a triangle equals to 180 degrees. Must then know different types of triangles, being the equilateral triangle, where all the sides and angles are equal and angles are equal to 60 degrees. Isosceles triangle, where two base angles and opposite sides are equal. And then also know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles in a triangle. And then also remember Pythagoras theorem, where you've got a right angle triangle, that c squared going to be equal to a squared plus b squared. Sometimes learners, they confuse this and then they would say c is equal to a plus b. That is not true. There must be those squares there. Otherwise, that is not Pythagoras. Pythagoras only holds if we square the lengths of these sides. Then if you look at some terminology of the circle, which you're going to look at in the next video.